India's #1 and largest IITM student community with 70,000 plus students on board. If you are preparing for the IIT Madras base degree qualifier, then you are in the right place because this is the best one-shot CT video enough to crack your qualifier CT. In this revision series, we will cover all the important computational thinking concepts, shortcuts, problem solving techniques, and exam oriented questions that you need for the qualifier. Whether you are revising at the last minute or strengthening your fundamentals, this series is designed to maximize your preparation. Before we begin, we are excited to announce that we have officially launched our IIT Madras BS Qualifier crash course. If you want structured preparation with expert guidance, this is the perfect opportunity to boost your qualifier score. Along with the crash course, if you are looking for one-to-one live class mentorship, 24/7 doubt support, strategy session, structured preparation, and previous year paper solving in live classes, you can join the India's #1 IIT Madras BS Qualifier coaching through the link provided in the pinned comment below. Our coaching program has consistently delivered 90 to 100% selection rate with top-notch faculty having a minimum of 10 years of industry experience. Our team owns 13 US patents in AI, ML, and IoT, and we also serve as guest lecturer at IIT where we teach advanced topics like LLM, RAG, and AI agents. So grab your notebook, stay focused till the very end, and let's begin the best one-shot CT video to help you crack your IIT Madras BS qualifier. Now, let us understand what are all the data sets that IITM is using to solve the questions in CT. Okay, in this course, we will find the patterns of computations and we use them to calculate quantities systematically across different programs using real data. We are going to ask real data. So, our goal is to ask questions about data, compute, and discover some useful insights. Okay, so see, first we will be using the school marks, that is report cards dataset. A typical report card has many details and can be complicated to process. It will contain name, gender, date of birth, town, where the student is from, and it will contain each subject and its respective marks. Okay, so this is how the school marks dataset will be. The next dataset will be shopping bills dataset. So the shopping bills have many details. We will use a simplified form like this. See, under SV stores, we are having some customer called Srivatsan, and he bought these items. And the type of items is food, toiletry, food, and the quantity, how much he have bought a particular item, and unit price, that is price for one, and the total means the price for the quantity he have bought. Okay, so total, and we will be having the grand total here. And at big bazaar we are having a customer called Akshaya. Same item type, quantity, unit price, and total. This is another store called Sun General. Okay, here also we are having a customer called Meena, where we will be listing the item type, quantity, unit price, and total, and we'll be having the grand total here. So using this, we can ask and answer questions across shops and customer. Which shops are doing better business? Who are the biggest spender? So does Srivasan spends more money or on food or toiletry? See, in this bill you can clearly says that Srivasan spends more in food than in toiletry. So see, who shops in all types of shops? Who shops in only one type of shops? All these questions you can answer from this data set, shopping bills data set. And the third data set we are using will be words from a paragraph. We take a paragraph and put each word in a separate card. So each card has a serial number, which is very important. This is very important because this will be the unique identity for each card. Okay, and each card will have a word and the type of speech of that particular word and the number of letters, letter count. This is what we call as letter count. Okay, so the word it is a type of pronoun, and the letters are 2. Okay, the letter count is 2, and the second word was the its type was verb, was a verb, and the letters count is 3. Okay, so now we can ask questions about the words. How many nouns are there? what is the longest word, which word appears the most. See, in this data itself, was appearing twice, right? So this was is appearing twice, so was is the word which appears the most. You can answer like this. Okay, how many verbs are there, how many sentences are there, how many letters are there in total. You can ask questions like this. Okay, so these are all the three data used by IITM to deliver this course CT. The first one is school marks, the second one is shopping bills, third one is words from a paragraph. Okay, so let's move on to counting cards using an iterator. So the goal is how many students are there. Let's find better ways to count. Okay, so we have these many report cards. We have to count how many students are there. So this is messy and we will lose track. See, 1, 2, 3, 4, 5. This is somewhat in an order, but if it is given in some shape like circle, if the report cards are arranged in a circle shape, you will easily lose the count, right? You cannot say which card I included in the count, which card I didn't include in the count. So this is the traditional method of counting. This will not be always convenient, because we may lose track of what cards we have counted. Okay, so this traditional method is neglected. So another method is bundles of 5. We can split them as 5. This one another 5, this one another 5, this one another 5, this one another 5. So like this we can split the cards as 5 5 5 5 5, and we can count like this: 5 10 15 20 25 30. So totally we are having 6 bundles. See, 1 2 3 4 5 6, we are having totally 6 bundles. Then 6 into 5 will be 30 cards. Totally there is 30 cards. Okay, and see, method 2 is keep track as you count. Write the number as you go. So at first you will be having 0 cards, right? So 0 cards means you write 0. Then you are seeing the first card, so 0 plus 1. Then you are seeing the second card. So my value is 1 here, so I have to add 1 to this one. Okay, so I have to add 1 to this one. So 1 plus 1 is 2. Then I am taking this value here. Then 2 plus 1 3. Then I am taking the next card, 3 plus 1 4. Then I am taking this card, 4 plus 1 5. Like this I am counting, and at the end I am getting 30 cards. So at the end we are getting the total number of cards as 30. Okay, see, this is what we call as the iteration. Let's see this briefly. The iterator pattern is the main idea here. Okay, first we set count is equal to 0. Then we take one card and move it to the counted pile, and we add 1. We count is equal to count plus 1. This is what we call as the iterator, right? Then when the first pile is empty, we will stop counting. Then the last value of the variable count will tell us the total number of cards. Okay, for example, we should start count is equal to 0, and the iteration condition for count is equal to count plus 1. So see the first card, I am seeing the first card, so I am writing count is equal to 0 plus 1. It's just 1. Then I am seeing the second card, the count will be 1 plus 1 2. Then I am seeing the third card, I am writing count is equal to 2 plus 1 3. So up to the last card I will be getting count is equal to 29 plus 1, which is equal to 30. So I got the count of the cards as 30. Okay, so during iteration, does the order of the cards you take matter? No, you can pick the cards in any order. See, as long as every card is moved once, the count will be correct. You do not have any particular order to take the cards. You can take from start to end, from end to start, or in a random order, or you can alternate them. Okay, so all these ways we have to visit every card, but remember not to skip any card. No skipping. Okay, not to skip any card, because it will ultimately affect the answer we are getting. Okay, so see here, now let's move on to filtering, iterating and computing with data. So filtering with two conditions. See how many girls are from Chennai. Okay, how many girls are from Chennai? So from the data we are having 30 students. We have first step, we have to keep only girls. So we have to separate boys and girls here. So after getting the girl cards, I'm neglecting the boy cards. I do not need boy cards because I need only girls from Chennai. Okay, so I'm leaving this boys out, and I'm taking the only the girls here in step 2. So from the girls, I'm going to filter them by city by keeping only Chennai. So if some girls are from Madurai or from Coimbatore like that, I'm skipping them all together. So and I'm keeping only the girls from Chennai. So see, first I had boys and girls, then I have skipped the boys. I got only girls. In that girls also, if they are only from Chennai, I'm keeping this. I'm keeping this. Otherwise, they are neglected. Okay. So I'm counting the remaining cards. That is only the Chennai girls. I'm getting count is equal to 5. So among 30 students, there are 5 girls from Chennai. This is how we filter with two conditions. Okay. So for that, how the pseudocode will be, we can see. Start count is equal to 0. Go through each card once. If gender is equal to girl and city is equal to Chennai, then count is equal to count plus 1. See, if gender is girl and city is Chennai, then count is equal to count plus 1. Okay, using this condition, you will get the required answer. Okay, and let's see how we will filter by date range. Count students born in the first half of the year, that is 1 Jan to 30 Jan. 30 June. Okay, separately for boys and girls. We have to do this separately for boys and girls. Okay, so condition for the first half will be date is greater than or equal to 1 Jan and date is less than or equal to 30 June. Okay, so it should be greater than or equal to 1st January and it should be less than or equal to 30th June. Okay, so name Vikram, gender is boy, and he was born in 6th May, so he will be selected. But see this Ajay boy, he is born in 22nd July, so we are neglecting him. Okay, so see how we will count this. Boy count is equal to 0, girl count is equal to 0. We are initializing two variables. For each card, if date is first half, if boy means if date in first half means this one, this condition. Okay, if the date is present in first half, if he is a boy, increment the boy count. And if the date is in first half and if she is a girl, if the card is a girl, and then increase the girl count. So after checking all 30 cards, you will get some data like this. So boys born in first half will be 8 members and girls born in first half will be 7 members. These are some assumption we are taking. Okay, so total is equal to 15, just half of 30. So they are nice and balanced. Okay, and also we can have another condition like who is doing better in mathematics, boys or girls. These are some examples. Okay, so to track this, we can take like this. Start all the 4 at 0. So we will be having 4 variables: boy count, boy sum, girl count, girl sum. Okay, all these 4 variables we are going to take as 0. The boy count will give us the number of boys, boy sum will give us the total max marks of boys, girl count will give us the number of girls, and girl sum will give us the total max marks of the girls. Okay, so we are going to start all the 4 variables as 0, and for each card, if the card contains the gender as boy, then we increment the boy count by 1 and boy sum will be max marks, adding the max marks to the boy sum. Okay, so see if the boy sum is 0, if a boy has got 98 marks, then the boy sum will become 0 plus 98. Okay, then the boy sum will now be 98. Then if you get another boy whose marks is 99, then this 99 will be added to this one. Okay, like this we are counting. So if the gender in the card is boy, we are incrementing the boy count and we are by 1, boy count by 1, and we are incrementing the boy sum of boy sum using the mathematics mark of that particular boy. Okay, and if the card is a girl, if the card's gender is a girl, then we will be incrementing the girl count by 1, and the girl sum will be incremented by the mathematics mark of that particular girl. Okay, so this is how we get the final answers. Boy count, this is boy count, this is the answer given by the variable boy count, which is 17, and this is the answer given by the variable girl count. Okay, and this is the answer given by the variable boy sum, and this is the answer given by the variable girl sum. Okay, so if we divide the max sum, so that is, if we divide the boy sum variable divided by boy count and girl sum by girl count, you will get the average of the average mathematics marks of both boys and girls. See, in this condition, the girls are scoring high, so you can conclude that girls are doing slightly better in mathematics. Okay, and see here, now let's see how we will design flow charts for iteration. Okay, so for iteration you have to count, add marks, etc. So we need some diagrammatic representation to understand these iterations easily. So there are two ways to describe algorithm. One, which is a flow chart, and another one is pseudocode, which we will be seeing later. Now we will be seeing the flow charts. Okay, so the basic flowchart symbols will be, the rectangle is used to represent a processor activity, which is a set of operations that changes the value of the data, like count is equal to count plus 1. These are all the process which change the values of the data, right? So they are represented by using the rectangles. Okay, so the arrow shows the flow of execution. It will say that after you got this answer, you have to move to this step, and after you are executing this step, you have to move to this next step. So it will show how the algorithm or the pseudocode flows. Okay, and this diamond or this rhombus, you can call it anything, or this rhombus shaped or the diamond shape is used to make decision. Okay, so it checks whether the condition is true or false. If true, it will direct you to one path, and if false, it will direct you to another path. Okay, and this oval shaped rectangle is used to mark the start and end of the program. Okay, and let's see an example for flow chart for counting the cards. See, start, so it is in oval shaped rectangle. Okay, start, we are initializing count is equal to 0. So are there more cards in pile 1? So if you are having cards, you are going to move to the S condition. If the pile is empty, you are going to move to the no condition, and you are ending it. Okay, so see here, if yes, you have to pick a card from pile 1, then move the card to pile 2, and you have to increment the count of 1. Okay, that is count by 1. You are incrementing the count by 1. Okay, that is, you are going to pick, you are going to move, and you are going to count. This is how we represent the counting of cards in a flow chart. Okay, so this is the template for any flow chart. Okay, first you have to start, then you have to initialize the variables. Any unvisited elements left? If yes, you have to move down. If no, you have to directly end the iteration. So when you move to the S, we have to pick the unvisited element and mark it as visited. For example, you have to move to the another pile, and after moving it, you have to update the variables using the informations you got in the card. Okay, got in the picked card. So update the variables, then you are going move back to this step where you will be checking whether there are any unvisited elements. If yes, you are doing this again. If no, you are ending the process. This is the common template, generic template for any iteration processes. Okay, see, and let's see a flow chart for sum. Okay, this adds the max marks of all students. This flow chart adds the max marks of all students. See, I'm going to start here, and I'm initializing sum as 0, and I'm checking if there are any more piles left in the card 1. If no, I'm going to stop. If the pile is empty, I'm going to stop. And if yes, I'm going to pick a card X from the pile 1, and I'm going to move the card, and I'm going to take only the max mark from that card. Okay, max mark from that card, and I'm adding to the sum. So my sum will be sum plus max marks. Then I'm moving it again there, and if there are any cards left, I'm going to move to the S condition. If there are no cards, then I'm going to move to the end condition. Okay, so this is the flow chart for sums. Okay, see, we are going to check the cards if the data is correct. Okay, so what to check on a card? We have to check whether they are having the correct type. See, name should be text and marks should be numbers. Marks should not be written like this. Okay, he got 99 marks. It should not be written like this. It should be only in numerical values, so that we can do all the computations like average, mean, median, like that. Okay, the allowed values for gender will be only male and female, and we have to check whether they are having valid range. The marks should be between 0 and 100, not minus 99. Right, this is wrong. And there should be reasonable values. So the class roll number should not be 7400, right? It will be 1 to at least 30 or some 50. It cannot be 7000, right? And there should be consistency between fields. If you are having a marks of a particular boy for 5 subjects, then it should add up to 500. It should not be 5, not 2 or 3. Then that will be wrong, right? So there should be consistency between the fields. Okay, so let us see some example for valid range. The roll number should be from 1 to n, which should represent the total number of students, and the marks should be between 0 to 100 according to the rule. Okay, or depending on the rule. Some exams may have negative markings, we don't know that. And the date of birth should be a real date. Okay, the date of birth should be a real date, that is from 2000 to today, from the year 2000 to today. Or sometimes they may have data of some old people. You will have the dates as something near 1990, like that. Okay, and gender is only male and female. You should not add any third gender into that. Okay, and there will be some common types of mistakes, which will be wrong value entered, value should be out of range, wrong type, and inconsistent data. That is, sum is not equal to total. In the shopping bills data, suppose you are having some 20, 30, 55 like this, but you got the sum as 65. Okay, see here, this is the total represented. Okay, but you add these things, 20 plus 30 is 50, 50 plus 55 will be 105. See, the sum and the total is not equal, right? So sometimes we will be having inconsistent data like this. So this may be some copy paste errors or editing errors, but we should be aware of what kind of data we are working on, whether it is right or whether it is wrong. Okay, so example from student card, the card number is a wrong type. See, card number cannot be a letter, so it should be a number. So how to detect? You should check if the value is numeric within the valid range. Okay, and see here, the marks is out of range. No subject, no examination, no exam center have the marks as 766. Okay, it will never lie under this range. Okay, and see here, in town or city, you are getting some value called Mira. Mira is a person's name, not a town or city. So this is a wrong value. Okay, and there are some other possible mistakes. Gender should be only male or female. This is X. These are all what we call as type errors. Okay, and DOB should be, see, 32 13 2025. You have no date of birth as no date as 13. Sorry, 32. No month as 13. So these two things are not valid, right? And max is equal to -5. In general examinations and in school types of examinations, negative marks are not there. Only in some examinations like NEET, JEE, there are negative marks. So for some general school exams, max is equal to -5 is not allowed. Okay, and the total is equal to 300. If the marks are out of 100, 300 is impossible, right? If the total mark for a subject is 100, then it is impossible for you to get 300, right? So you have to aware of what data you are facing before you do some calculations, so that you will get the idea, so that you will get the answers correctly, so that you will not be working on the inconsistent or invalid data. Okay, so that brings us to the end of this session. This is just part 1 of our best one shot CT video in 2 parts. Part 2 will be released very soon, so stay tuned. The link to the next part will be available in the pinned comment and added to the playlist. And if you found this revision session helpful and want to complete the qualifier preparation with live classes, one-to-one mentoring, 24/7 doubt support and structured practice, previous year paper discussion, and our newly launched qualifier crash course, call the number provided in the pinned comment below. If this video helped you, don't forget to like, share and subscribe to the channel so you never miss our IIT Madras BS qualifier content. Thank you for watching. Keep practicing, stay consistent, and I'll see you in the part 2. Until then, all the very best for your IIT Madras BS qualifier. Let's crack it together. Welcome to India's #1 and largest IITM student community with 70,000 plus students on board. If you are preparing for the IIT Madras BS degree qualifier, then you are in the right place, because this is the best one-shot CT video in 2 parts. This is the second part, which is enough for you to crack your qualifier computational thinking. In this revision series, we'll cover all the important CT concepts, shortcuts, problem solving techniques, and exam oriented questions that you need for the qualifier. Whether you are revising at the last minute or strengthening your fundamentals, this series is designed to maximize your preparation. Before we begin, we are excited to announce that we have officially launched our IIT Madras BS Qualifier crash course. If you want a structured preparation with expert guidance, this is the perfect opportunity to boost your qualifier score. Along with the crash course, if you are looking for one-to-one live class mentorship, 24/7 doubt support, and structured preparation, and previous year paper solving in live classes, you can join India's #1 IIT Madras BS Qualifier coaching through the link provided in the pinned comment below. Our coaching program has consistently delivered 90 to 100% selection rate, with a top-notch faculty having a minimum of 10 years of industry experience. Our team owns 13 US patents in AI, ML, and IoT, and we also serve as guest lecturer at IIT, where we teach advanced topics like LLM, RAG, and AI agents. So grab your notebook, stay focused till the very end, and let's begin the best one-shot CT video in 2 parts. This is the part 2 to help you crack your IIT Madras BS qualifier. So, in the last part, we saw what are all the data set we'll be using for the patterns of computation, and how do we count chord using an iterator, and how we filter, iterate, and compute the data, and how the flowchart representations for iterations will be. The rectangle means processor activity, arrow defines the flow of the execution, and the diamond shape will give us the decision statements, and this oval shaped rectangle will mark the start and end of the execution of iteration. So, and then we also saw how to find some using flowcharts with filtering, and we also see how we should check if the data is correct or not. Okay, now let's move on to the next contents. What will be the data types, values, operations, and their restrictions? So in general, why do we need data types? Each field on a chord has restrictions on the values it can take. See, only certain operations can make sense on that data. See, you cannot add 2 names, right? You cannot add 2 names, but you can count that name. You can count the name and you can say these number of individuals are there in this data set. Similarly, in the marks, you can perform addition, subtraction, multiplication, division and all that. For these marks, you cannot find the part of speech, right? For the name, you can find the part of speech, letter count and all these things. But for the marks, you cannot find POS or letter count. Similarly, for the marks, you can find mean, median, mode. But for the name, you cannot find mean, median and mode, right? So for certain data types, only certain operations are possible. So to know which operations are possible for certain data types, certain data, we will be using something called as data types. Okay, so data types tells us let us tell the computer which values are allowed. That is, it will help us set a range. Okay, and for which types of values, what are all the operations allowed. Okay, so if it is a nominal variable, you can only count. Okay, you can only count. Otherwise, if it is a marks, you can do mean, addition, subtraction, median, mode, everything you can do, right? So see the example from the student cards. Wrong type or invalid value. Here card number is Q. Card number is Q, right? A card number should be a number, it cannot be Q. So this is wrong. Okay. But see, the name is Arjun, this is right. Gender is male, this is right. Date of birth is a valid date of birth, so this is right. Town or city is Chennai, this is also valid. Max marks is 72, valid. Physics marks is 81, valid. Chemistry marks is 64, this is also valid. And the total is also correct. Okay, and the total is also correct. So everything is valid in this card except the card number. Okay, and see, here we will be seeing the example of out of range and total mismatch. Card number 72, so this is correct now. Name Aditya, correct. Gender male, correct. Date of birth is also correct. Town or city is Velur, correct. Mathematics is 84, correct. Physics is 92, yes, it is within the range, so correct. Chemistry is 766. 766 is out of the range 0 to 100, so this is invalid. Okay, so we know the total is 252 and the max and physics marks like this. So using this total and this max and physics marks, you can find the chemistry marks like this: 252 minus 84 plus 92. Okay, which is 252 minus 176, which is 76. Okay, so the chemistry marks is 76. It was wrongly typed as 766. Okay, and see here in this data, the card number is 18. Okay, this is reasonable value, valid value. Name is Meera, this is also valid. Gender is female, this is also valid. Date of birth is also valid. Town or city is also written as Meera. No, this looks like a copy paste error. Okay, town or city should be a city name, not a person's name. So this is wrong. This data is wrong. This seems like a copy paste error. Okay, and let us see what is a data type. A data type defines a set of valid values for a data element and the operations that can be performed on it. See, whenever you are having a variable named marks, the value should be set to 0 to 100. Only in some special types of exams you will be having some other range for marks. So a data type helps us define the structure of how the value will be. So for this data type, the value should be like this. You cannot give anything. If you are giving a numeric data type, then you cannot type 9 like this, right? It should be like this. So these are all some guardrails so that you will not give some vague data into the system. Okay, so it helps the computer, this data type helps the computer to check the values are within the permitted range or set, only allowed operations are used. So what are all the basic data types we have seen? The first one is Boolean, which means truth values. It will say either true or false. It will have only two values which are true or false. And the operations allowed in the Boolean data type is and means it check whether the both conditions are true, Or means it will check whether any of the one condition is true. Not means negation, which means both the conditions are not true, and equality means both the conditions are equal. Okay, and the result type will be always boolean, that is the result will also be either true or false. Okay, see for example, if this gender is equal to male, gender is equal to male means it will give us the answer as, if the gender was male it will give us true, if the gender was not male it will give us false. So see, the answer is in boolean. Okay, is DOB in range? If it is in the range then it will return true, if it is not in the range then it will return false. Okay, so see, both conditions true, that is if gender is equal to male and DOB is in range, then we will put true or it will be false. So this is how we use the boolean data type. Okay, then let's move on to the integer data type. Integer means it will be whole numbers. This whole numbers includes minus infinity to plus infinity. Okay, minus infinity to plus infinity. So any integers like this will be the will come under the integer data type, and there will be no decimal part, can be negative, positive or 0. Okay, so the operations possible are addition, subtraction, multiplication, division, and comparison can also be done. Equal to, greater than, equal to, not equal to, less than or equal to, less than, greater than or equal to, greater than. All these comparisons are possible, and the result will also be an arithmetic integer. For all these arithmetic operations the result will be integer. For the comparison operation the result will be boolean. Okay, so for example, roll number, marks, physics marks, chemistry marks, and the totals are all integers. Dates are also integers. So division is an integer only if the remainder is 0. Okay, only if the remainder is 0, or you have to ignore the remainder if you got any. In this condition, then the division will also be included in the integer section. Okay, and now let's move on to another data type called character. Character means single symbol. The single symbol can be alphanumeric, that is capital A to Z or small a to Z or 0 to 9. Okay, the special characters are also included, like full stop, comma, semicolon, colon, asterisk, slash, percentage, brackets, and more. And the operations possibles are equality. Equality means it will be like comparison. We will be comparing whether the two characters are equal, same or not. And the result type will be boolean. It will be either true or false. So for example, for this character data type will be, how we'll be using character data type will be, is the last character ends with full stop, is the last character ends with a full stop, and it is used to compare the characters. Equality only in our data. Okay, so the conclusion is data types give structure and meaning to data, and they help us validate data and ensure we use the right operations. So good data will result in good results. Okay, and data types restricting values and operations. Okay, why do we need data types? Now we saw what are all the different data types available. Now we are going to understand what is the need for these data types. Each item on a card has restrictions on its value. Only certain operations make sense for each values. So data types let us define the valid values and allowed operations so that the data says correct or sane. So if you know the data type, see, if you know the data type is numeric, you will perform only numerical operations in that variable. Okay, if you know that a variable is categorical, then you will not perform computations like addition, subtraction, multiplication in that variable, so that it will not cost you some assessment time. Okay, so what does a data type do? Data type tells its computer how we intend to use the data, check that values are within the permitted range, allows only permitted operation, rejects invalid values or invalid operation. This is a data types serve as a time saving character. Okay, so that we can perform only valid operations instead of wasting time on the invalid operations. Okay, so we already introduced the basic types, which are boolean, integer and character. And means both true, or means any one of the condition is true. Negation means both are not true. Equality means they must be equal. Okay, so truth and truth means A and B will be truth. Truth and false will be false. False and truth will also be false. False and false will also be false. Okay, so this is the general truth table notation. How we will come to a conclusion according to the truth table. Okay, and the integer, the operations performed are arithmetic, that is addition, subtraction, multiplication, division, modulus, and all that, power, and all that. And for the comparison, you will be using less than, greater than, equal to, not equal to, less than or equal to, greater than or equal to. So for arithmetic operation, the result type will be integer, and for comparison operation, the result type will be boolean. Okay, and see, for character, the operations performs will be comparison, equality or not. Okay, so there are some subtypes that we subtypes of data subtypes of data types that we use in our data sets in this CT course, which will be sequence number. Okay, sequence number is based on integer, and the valid values or constraints are 0 to max. Sequence number max could be 100 or 10,000, etc. Max could be anything, the maximum value could be anything, right? The allowed operations are comparisons only. The not allowed operations are arithmetic operations. So arithmetic operations are not allowed, and comparison operations are only allowed. So examples from our cards will be, card numbers is 0, 1, 2, etc. So the invalid values are -1. Card number cannot be negative, right? It Card number denotes the count of the number, and it cannot be negative, so -1 is out of range. And this is something which is 10 lakhs. We will be not having 10 lakhs in our data, and sequence number cannot be 10 lakhs, right? So it will be out of range. And see, the marks. Marks is also a subtype we will be using. Physics, maths, chemistry, and total marks. Okay, it is based on the integer, and the values will be 0 to 100. Okay, 0 to 100 only. Total means it will be 0 to 300. Since we are adding 3 subjects, physics, maths, and chemistry, the total will be 0 to 300 only if 3 subjects. Okay, the operations possible are addition, subtraction, comparison. The operations are not allowed are multiplication and division. Okay, so see, the marks 84, 92, 76, 64.5, all these marks are valid because they lie in the range 0 to 100. Okay, and the invalid marks will be -5, 77, 766, 3000.34. These are all out of range or too many decimal places. So these are all the invalid values, these are all the valued marks. And we also know that count is the number of cards or number of boys or number of girls. It is based on integer type, and the count will be from 0 to max. Max is the data set size which can be up to 10,000. Okay, the arithmetic operations which are possible are addition, subtraction, and comparison. Multiplication and division are not allowed for the count. Okay, so the count can be 0, 5, 17, 267. It cannot be -3, as a count cannot be negative, and it cannot be like this. This will be out of range. Okay, and another subtype is gender, which have 2 characters, which one is male and one is female, and it is based on the characters. It is based on the character data type, and there will be only 2 values, which will be one will be male and one will be female. Okay, and the only one common operation performed for this data type will be checking the equality. Okay, is that card is equal to, is that card's gender is equal to male, is that card's gender is equal to female. That's the only thing we will be checking, right? So you will only have values m and f. Invalid will be a, one, male, female. Only m and only f. You cannot even write male or female. Okay, and the next subtype will be string. Okay, string is general. it will be a sequence of characters. It can be any sequence of characters, any length. It can also include special characters, digits and letters. See, it contains, it starts with and it ends with. These are all the operations performed in the strings. See, you can check whether some letters are contained in a string, or if a string is starting with a or ending with n, like that. Or you can use also do equality comparison. Okay, so Arjun, Chennai, It, Vedanayagam, these are all any length strings. Okay, and subtypes of strings will be name, city and word. Okay, so in names, there will be no digits and no special characters, only letters. Similarly, for city and words, there are some letters and some special characters like full stop, comma, semicolon, colon, etc. Okay, and for all these three subtypes of strings, the operation that can be performed will be equality comparison. Okay, and let's see a category of a word. Okay, so category of a word in general represents the part of speech of the word: noun, verb, adjective, adverb, pronoun, preposition, conjunction, interjection. So these are all the constraints for this subtype, which is a category. So in general, in simple words, the finding the POS of a part of speech of a word will be called as the category of a word. Okay, and using this category data type, you can perform only equality comparison. Okay, now let us see why we need subtypes when it's not so obvious. Okay, so why we need subtypes? Our data contain restrictions on values and useful operations. We create subsets of basic data types to capture these restrictions and support meaningful operations. Okay, so basic types, what are all the basic types? Boolean, integer and characters. So Boolean will have true or false, integer will have minus infinity to infinity, only whole numbers, and characters will have letters, digits and special characters. Okay, so why do we need the date subtype? Okay, date subtype. So if the problem states date like 4th June or 31st January looks like strings, but we need to compare the date, add days and do other operations. So for doing all these things, we will be using the subtype date. Okay, so represent a date as the day in the year. Okay, let 1st January is equal to 0, then 2nd January is equal to 1, then 31st January will be equal to 30, then 1st February is equal to 31, and the last day will be 364, which is 365 in a leap year. Now it becomes an integer. See, data type as a subtype of integer. We have got date as a subtype of integer. So see here, the range of values will be 0 to 364, which means 365 in leap year. Okay, the allowed operations are addition, subtraction and comparison. Not allowed are multiplication and division. The conversion are to integer. 4th June will be 154. Print 154 will be 4th June. Okay, the count of days. Okay, now we can compare dates, add days and using integer operation and print them in a readable form. So second one, we will be having fractional marks. This is also a subtype of integer. Marks like 62.5, 74.25 have decimal places. So storing them as 62 or 63 will lose the information. Will lose the information by 0.5. Okay, so we will not do that. Solution, we will be storing the two decimal places as an integer by multiplying by 100. Okay, so if you multiply all these datas by 100, you will get 6250 comma 7425. So the decimal places are all removed. Okay, now you can store them as 6250 and 7425. After doing all the interpretation, you can again divide them by 100 to derive the right answer. Okay, and let us see how amount or price will be used as a subtype of integer. So the prices like 27.50, 145.75 have decimal places. Again, we can multiply them by 100 to get 2750, 2750, and 145.75 will be written as 14575. So we can convert these decimal values into integers and store them inside the table. Okay, and let us see how they will convert quantity also. Quantity will also be decimal items. For decimal items, you will just multiply them by 100 and store them as 125. Okay, now data types as records and lists. We already defined basic data types, boolean, integer and character, and many subtypes like date, name, string, like that. Now we combine them into larger structures which will be records and lists. Under the records we will be having tuples, structs and classes. So the key idea for this lecture will be a data item can contain multiple fields of different types. A list is a sequence of items. So a data item contain multiple fields of different types. So a data item is a combination of different fields of data types. Okay, but a list is a sequence of items. Okay, usually all of the same type. In the items in the sequence will always be of same type. Okay, so see here, how will the marks card record be? This is how the card will be. Okay, the card number is 9. The name is Arjun. Uh, Gender is male. The date of birth is this. He comes from the town or city, Chennai. And the max physics, max and chemistry. And this is the total marks. Okay, now we are going to change them into a record. Okay, change them into a record. Record means what are all the variables that are in the card. Okay, record means what are all the variables and the data types present in the card. See, first he is having sequence number, which is a sequence number data type. Okay, and then he is having a name, which is a name subtype, and then he is having gender as male. Gender is also a subtype, right? Then he is having date of birth, DOB, which is a date subtype, and then he is having his town or city as Chennai, which is a city data type. And this physics marks will come under the marks subtype, and max mark will come under the max subtype, and chemistry marks will also come under max subtypes, and total marks will also come under mark subtype. Okay, so this one single card has 1 2 3 4 5 6 7 8 9 fields. Okay, so this one simple card has 9 fields within it. Okay, see the second example, word in a paragraph record. So see, first we are given the sequence number as 0, and then we are given a word, and we are given the part of speech of that particular word, and then we are given the letter count of the word. So see here, 0 is the sequence number of that word. It is the word present in the para, and pronoun is the part of speech of this particular word, and 2 is the letter count of this particular word. Okay, so the field names are sequence number, which is the data type as sequence number. Word is a word data type. These are all subtypes. Okay, and category is the category subtype, and letter count is the count subtype. Okay, so this single card has four fields. Okay, so now let us see what are all lists will be. Marks cards list will contain sequence of marks card. Words in para list will give a sequence of words in para, and shopping bills list will give us a sequence of shopping bill. Okay, so see here, mark cards list, we will be having card 0, card 1, card 2, etc. card n minus 1. Okay, so this is what we called as a list of records. Okay, where all the elements are of same type. See, first card I got the physics marks as 72, so I'm writing 72. Then I'm getting the again, and the next card I'm getting the mark as 82. Then I'm getting 99. So this is what, see, this is the physics marks of person 1, this is the physics marks of person 2, this is the physics marks of person 3. This is what we call as the list. Okay, this is what we call as the list. So a shopping bill record, which is a record containing a list of another record. Okay, see here, customer name is Meera, bill number is 15, the items are rice, tur dal and oil, and the quantities are given and the price are given and the total cost is calculated and the overall total is also calculated. So see, there are 5 different fields here. First one is sequence number, which is the data type as sequence number, and the store name, Sri stores, right? This is the data type, subtype of name. And customer name, Meera, this is also a subtype name, right? Total amount 350 is also another subtype amount. And items, there are 5 items, there are 4 items. So 2 plus 1 plus 1, 4 items. There are 4 items, and this items field is also having the data type item list. Okay, so this is what we call as the list here. Okay, and then let's move on to iterator with find and stop. Okay, so see here, the problem here is we are going to search through a collection. As soon as we find what we are looking for, we are going to stop the iteration and exit cleanly. We are going to exit at the same point where the iterator normally exists. Okay, so see the student example. We are going to find a student with marks greater than 90 in physics, chemistry and maths. So see here, Amit, we are going to find a student with marks greater than 90 in physics, chemistry and maths, which means that one student should have marks greater than 90 in physics and chemistry and maths, which means that he has to get 90 above in all the 3 subjects. We have to find the students with the marks above 90 in all the 3 subjects. Okay, see, Amit, greater than 90, false. This is greater than 90, okay, but this is not greater than 90, false. So we have to have all the 3 subjects as greater than 90. Here it is failing, so I am rejecting Hamid, so I am skipping him. Okay, see here, 62 is less than 90, 91 is greater than 90, and 88 is less than 90. Only this one is getting selected and these 2 are becoming false. So I am rejecting both, as we need a student with marks greater than 90 in all the 3 subjects. Here we are having only one subject, so we are neglecting this. And see Chitra here, 90, which is not greater than 90, and 89 which is less than 90, and 93 which is greater than 90. Only one subject Chitra has scored more than 90, but we need a student who has scored 90 greater than 90 in all the three subjects. So we are skipping Chitra. Okay, and now let's move on to Neha. 91 is greater than 90, 95 is greater than 90, but 88 is less than 90. Since we need a student who scored greater than 90 in all the 3 subjects, Neha has scored greater than 90 in only 2 subjects, so we are neglecting Neha. Now see Rahul, 96 is greater than 90, 93 is greater than 90, 91 is greater than 90. So we have found a student with the marks greater than 90 in all the 3 subjects. So Rahul is the required answer for the question given. So since we have found Rahul, we are asked to find a student with greater than 90. So we choose the first student with greater than 90 in all the 3 subjects and we stop here. Okay, so we found the first student satisfying the condition. No need to look at the remaining cards. Okay, and see this shopping bill example. Find the first bill that has items from three different categories. Okay, so see here in the first bill there was only one category which is food. Second bill only one category which is food. Third one there are two categories. Since we need three categories, we are neglecting the bill number 3 also. See the fourth bill, we are having two, stationery and food. See the fifth bill, we got food, apparel and toiletries. We have three different categories in one bill. So we are selecting this bill and we are stopping the iteration here. We stop as soon as we find the first bill with three different categories. Okay. So see here, let's see another example using the words data set. Find the first verb in the third sentence. Okay, so we are going to locate the first verb in the third sentence. It was Monday. It was Monday. Here was a verb, but it was not a verb in the first verb in the third sentence. So since it is not sentence 3, we are neglecting this. Okay, see, Swaminathan was reluctant to open his books. This is also a verb, but since it is not a verb, not a first verb in the third sentence, since this is sentence 2, right? So we are neglecting this. Now we are going to move to sentence 3. This is where we have to find the first verb. Okay, so see here, he reached the school and saw something on the way. So this is the third sentence. So here reached is the first verb in the third sentence. So we found the first verb in the third sentence. No need to examine the remaining words. Okay. So this is also a verb. This is also a verb in sentence 3. But reached is the first verb in the sentence 3. Right. See, we are asked to find the first verb in the third sentence. Reached is also a verb, saw is also a verb, but reached is the first verb in the third sentence. So we stop the iteration after locating this reached. Okay. So let us understand the right way to denote this iteration in a flow chart. So first we have to initialize, that is we have to keep the found as false. Is there any other card and not found? We have to examine the card. Yes, we have to examine the card. Is it the correct card? If it is yes, we have to change the found as true. If it is no, we have to move the card to the next pile and go to the next card. Okay, then same we are repeating repeating this iteration again and again until the pile is empty. Okay, after the pile is empty, we will exit the iteration. Okay, so see here, why can't we just exit from the middle? See, I properly said that we have to check if there another card. If not found, we have to move to this normal exit. We cannot quit in the middle just because we cannot find a card matching the condition in this flow chart. Okay, we cannot exit like that. Why? Let us see why. If we jump out from the middle, we may leave the collection in a messy state. More importantly, we may not reach the same exit point where the iterator normally finishes. So, since we will be not reaching the exit point where the iterator will normally exit, we will not exit the iteration in the middle. Okay, so flow chart with side exits becomes messy. Flow chart with side exits like this will become messy and hard to reason about. Okay, so let us see how it works. Initially, we have to keep found is equal to false so that we can set that not found as true. The loop continues while there are cards. When we find the desired card, we set the found variable to 0. So on the next check, if not found, it will again become false. So the loop stops even if the cards remain. So we exit at the same normal exit point. Okay. So this is why this is useful. We do not waste time after finding the answer. We'll just exit the code. See here and all, we found the bills with 3 different categories and we exited the code, right? That's what we will be doing. We do not waste time after finding the answer. After finding the answer, you have to quit the code. Okay, so when the loop stops, we can check found. If found is equal to true, then the item exists. If found is equal to false, we examined every data, but it does not exist. Okay, so let's move on to the next slide. Finding the maximum value in a set of cards. So what problem we will be solving under this categories? We already found averages before. Now we want to find the student with best total marks. Okay, so best total marks. We must scan all the cards and keep the highest total marks seen so far. So the final answer will be 281. The maximum total marks will be 281, like that. Okay, so see, there are many methods to solve this question. The first will be card method. So keep the current highest card separately. So this is a physical method we will be doing. So we will be passing the cards over and over. We will be reading all the cards from the top. We will keep the current highest. The We'll keep the current highest, which seems highest to our eyes, separately, and we'll read the next card. If the next card is bigger than the first current highest card, we will replace the card, and if smaller, we'll keep the card to the another pile and move until we get a card which replaces the current highest card. Okay, so we'll continue till all the cards are checked. See here, first we will be getting 240, then 252 is greater than 240, so 240 will be replaced by 252 for the current highest value. Then again I'm getting 276, which means 252 will be replaced by 276 for the highest total marks. Then again I'm getting 281, then which means 276 is less than 281, which means 281 is the greatest. Therefore 281 will be replacing 276 and becomes the current highest marks. Okay, in this process we have to skip 196 because 240 is greater than 196, and also we have to skip 210 because 240 is greater than 210. Again we will be skipping 244 because 252 is greater than 244. So we will be checking only the highest values here. Okay, now this is the physical method. This is the traditional or conventional method, anything you can say. Now let us see what will be the variable method. Okay, so let us create a variable called max and we initialize it to 0 because a mark cannot be below 0. Okay, so we will be reading one card at a time and we'll comparing the card total with the max, and if the total is greater than max, then max will be equal to total. Okay, else if total is less than max, we will be not doing anything. We will just move the card to the next pile and continue the iteration and until the pile is empty. Okay, so after all the cards, max will store the highest marks. We know a trick from the GT. If you saw the CTGA videos, you will know this trick. To find the maximum values, you have to take the variable max is equal to 0, and to find the minimum values, you have to take the variable min is equal to 100 or 10,000 or 1,000, like that, whatever the specified data types ranges. Okay, so let us see a step-by-step example for this variable method. See here, at first I'm initializing max is equal to 0. Okay, so if I'm initializing max is equal to 0, and if max is equal to 0, and if total is greater than max, then max will be equal to total. Okay, if total is greater than max, then max will be equal to total. See here, max is equal to 0. Max is equal to 0. The card total is 174. 174 is greater than 0. Therefore, the new max will be 174. We know that if max is To say in other words, max is equal to 0. If total is greater than max, then max is equal to total. This is the condition. Okay. Now see here, 174 is less than 0. So the new max will be 174. Okay. 209, which means 209 is greater than 174. Therefore the new max is 209. 227 is greater than 209. So the new max will be 227. The next total is 219. 219 is less than 227. So see here, only if total is greater than max, we will be replacing max is equal to total. But here it is less than. So we will not updating the max variable. Okay, so 254 is greater than 227. So we will updating the max variable to 254, and 261 is greater than 254. Therefore we will updating the variable as 261. Okay, and 221 is less than 261. So since the less than condition is occurring, we will not be replacing the maximum. We will not be updating the maximum variable. And since 281 is greater than 261, we will be updating the max variable to 281. Now the variable max is equal to 281. This is the highest mark, that is the maximum mark in the data set. So the final max is 281. This is the algorithm or the pseudocode used for finding the maximum value. So we'll set max, the algorithm or pseudocode, max as 0. For each card, if total marks of card is greater than max, then max is set to total marks, then print max. So we will update only when we see a bigger value. Okay. So see here, similarly, if you want to find the minimum values, you have to set the minimum to 100 or 1000 according to that question range. Okay. So important thing for you to remember means if you have to find the maximum value, then you have to set the variable max is equal to 0. If you have to find the minimum value, you have to set the minimum variable as 100 or 1000 or 10,000 according to the question's range. Okay. Now let's move on to finding the longest sentence in a paragraph. Okay. Now let us see how we will be finding the longest sentence in a paragraph. So the big idea is we will be scanning the words once, and we will be counting each sentence, and we will be keep updating some variables until we found the longest sentence length so far. Okay, so the key concept or definitions will be a sentence will end with a period or a full stop. Okay, so the count will be equal to the number of words in a current sentence, and the longest variable will be equal to the maximum number of words in any sentence. Okay, and there will be two variables, which is count variable will be the number of words in a current sentence, and the longest variable will be the number of words in a sentence so far. Okay, longest number of words in a sentence so far. Okay, so the rules or the steps for this algorithm will be, first we have to initialize two variables, longest and count is equal to 0. We have to read words one by one. If the word ends with a period or a full stop, this is the end of the sentence. So if count is greater than longest, if count is greater than longest, then longest is equal to count. Then we have to set reset count is equal to 0 for starting a new sentence. Okay, or else if count is not is greater than if count is not greater than longest, if count is less than longest, we'll be incrementing count is equal to count plus 1. Okay, so after the last word, the longest has the length of the longest sentence. After the last word, the variable longest will have the length of the longest sentence. See, first we have to start and we'll be reading the next word. If it is ending with a period, we will move to this one. If count is greater than longest, then longest is equal to count, and then count is reset to 0. If not, we will be just incrementing count is equal to count plus 1. So the iteration will end after attaining the last word, after going to reaching the last word. Okay, so let's see an example walkthrough. Let's see an example walkthrough. See, the word here is it was Monday morning. So we are ending here with a period. So it, is it a period? Is it ending with a period? No. Was, is it ending with a period? No. Monday, is it ending with a period? No. Morning, is it ending with a period? Yes. See the action here. First the count was 0. First the count was 0. See, now I'm getting it. Okay. See, I'm getting it. See here, the sentence is it with no period. Okay. So see, is it having a period? Is it having a period? No. Then I have to set count is equal to count plus 1. Okay, count is equal to count plus 1, which means my count is 0 now, and I'm not having a period here, no period. So I have to set count is equal to 0 plus 1, which is 1. So the count is equal to 1 here. Okay, now I'm moving to the second word, which is was. Okay, was means was is also not ending with the period. Okay, then I have to move to the no decision, where I have to increment the count again. Therefore count will be now 1 here. Now count is 1 plus 1, which is 2. So the count is equal to 2 here. See, 1, 2. And Monday is again not ending with the period. Again I have to increment count. So count will be 2 plus 1, which is 3. Okay, 3. And see here, now morning is ending with the period. Therefore if ending, I have to move to the S. Now I have to compare count with longest. If count is greater than longest, see, my count variable is now 3, my longest variable is still 0. Therefore I have to take the longest is equal to count. Longest is equal to count. See, count is greater than longest. The condition is becoming true here. So then I have to set longest is equal to count. Longest is equal to 3 now. The longest is equal to 3 now, and then I have to count is equal to, and then I have to reset count is equal to 0. Okay, see, I have to increment the count by 1, and then I'm going to update the longest as 4. Okay, so the longest will be 4. Then the process continues for all the variables, and then it will be finding the longest length of a sentence. Okay, so this is how the iteration will be happening. This is how the iteration will be happening in that. Okay, so see, now the common traps or mistakes we'll be doing is not resetting the count after a period. Okay, so sometimes we have to reset the values of the variable to get the exact count here, and updating longest at wrong time. We have to update the longest after after meeting a word with a period. Okay, we cannot do it in the middle. So treating comma or semicolon as the end of the sentence is also wrong. Only full stop will denote the end of the sentence. And confusing the words with characters will also lead to some mistakes. Okay, so the things to remember is always have to start with longest is equal to 0 and count is equal to 0. And we have to increase the count for every word. And on period, we have to compare and update and then reset the count variable. And at the end, we have to find the longest variable which holds the answer for the longest word in the sentence. Okay, longest words with sentence. Okay, so we compare one variable count with another variable longest to get our required answer. Okay, Now let us see counting bills per shop. Now we have already saw counting of bills for all the shops, but we have to do this uniquely for one particular shop here. Okay, so the big idea is we don't know how many shops are there, but while scanning the bills one, we can find their names, right? We can separate the shopping bills according to the name of that shop, right? So create a new count for every new shop, and we'll be updating the count for existing shop. Okay, if you are see while counting, if you are meeting a new shop, then you will be creating a new variable for that shop. And we are and if you are getting a card with the existing shop name, then we have to just update the count for that shop. Okay, so the goal is to find which shop generated the most bills. Okay, the goal is to find which shop generated the most bills. We don't know how many shops exist in advance. Sorry, we don't know how many shops exist in advance, so we are keeping a count for each stop. We are keeping a count for each stop. If one shop is new, we are going to start the count is equal to 1. If the shop exists, we are going to add 1 to its count. We are going to add 1 to that particular shop's count. Okay, so after counting all, we will be finding the maximum count. Okay, so let's see the algorithm or steps for this goal. First, we have to initialize an empty shop as count. See now, for example, let us say we are having some shop A, and its count will be count A. And if you are having shop B, then its count will be count B. If you are having a shop C, then its count will be count C, like this. Okay, for each bill we have to read the shop name yes, and if yes is already in the list, if the yes is already in the list, now we are having three shops, right? Count A, count B, count C, like this. We are having three shops. If the shop name is already in the list, we have to just update this one. See, if I get the first card as A, okay, then I have to increment count A is equal to count A plus 1. Okay, otherwise, if I get a card with the shop name as D, then I have to create a new variable called count D is equal count D, and we have to set it to 1. Okay, see, if I get the card as a card with the shop name A, B or C, I have to just update the count variable of that particular shops, that is count A is equal to count A plus 1, count B is equal to count B plus 1, count C is equal to count C plus 1. Okay, I have to do like this. Otherwise, if I'm getting a card with a new shop name called D, then I have to create a new variable called count D, and I have to set it to 1. Then again, if I encounter a bill with shop name as D, then I have to write count D is equal to count D plus 1. Now it is not new, right? Then now the shop D will become existing shop name when we get the shop name D for the second time. So then we will be doing count D is equal to D plus 1. Okay, so this is the algorithm steps, and after all the bills are processed, we will be finding the shop name with the maximum count. Okay, so this is how the flow chart will be. So we are going to start and read the next bill where the shop name is equal to S. If S is already present, means then we have to set the count of S is equal to count of S plus 1. If it is not present already, we are going to add a new entry and set it to 1. Set its count to 1. So after all these process, we are going to end the 1, and we are going to get the maximum count here. So let's have an example walkthrough. See, first one is SV stores. Okay, this is a new shop, so I'm starting 1. So I'm keeping the count for SV stores as 1. and no big bazaar, no send general, so dash. Again I'm getting big bazaar, new shop, and I'm starting at 1. It is not SV stores, so I'm keeping the SV stores as 1. Last step I didn't have any big bazaar. Now only I'm newly creating big bazaar, so I'm setting it to 1. And sun general is not, or is also not present here. SV store, it is already existing here, so I have to just increment discount. So 1 plus 1, 2. Big bazaar is already one time only. I have not made it for second time. I have not got it for second time. So it is just 1. Sun general was not even acquiring for the first 3 steps. So I am keeping it as dash. Okay. Then again I am also getting SV stores. Then I am again incrementing the value for SV stores. It will become 3. Big bazaar has not occurred for second time. So it is 1. And sun general is never happened. Has never happened. So it remains as dash. See the fifth one. Fifth step, I'm getting big bazaar, so it is already existing. So now XP stores are not incremented because only big bazaar is opening for the second time. SV stores stays in the third count, so I'm keeping SV stores as 3 while updating the big bazaar to 2. Sun general has never occurred here. Okay. See, the sixth step only, I'm getting sun general as new shop, not existing, right? For all these 5 steps, sun general has not existed. So it is a new step. So I'm going to start at 1. So I'm going to set it as 1. Okay. So this is how the iteration will be happening for count of bills per shop. Okay. So this will be the count of bills per shop. Okay, this is how we do this process. Now let's move on to total bill value per shop and finding the max in one iteration. Okay, so we'll be finding the total bill value, and we'll be also finding the maximum value in one iteration. So the big idea is add up all the bill amounts for each shop while scanning once and keep updating the maximum total we have seen so far, so that we will keep track of the total amount and also the maximum amount. Okay. So let us see the algorithms here. Initialize an empty map or dictionary, that is shop as total amount. Okay. So again the same. A means total of A. B means total of B. C means total of C, like this. Okay. And I'm also going to set max is equal to 0. Since I have to get the maximum total of a bill of a shop, we will be also setting max is equal to 0. So for each bill, I'm going to read the shop name yes and amount A. Okay. So if yes already exists, if the shop already exists, then A will be equal to the total A plus that amount in that bill. Okay, plus the amount in that bill. If it is not existing shop, then you have to create a new variable called D, and you have to create a new shop called D, and you have to maintain a variable total D, which is equal to the amount in that bill. Okay, you are going to initialize a variable called total D with the value of the bill amount in that particular bill. Okay. So after adding A, we have to compare it with max. So if total of that particular shop is greater than max, then max will be total X. So after all the bills are processed, the maximum is the highest total bill value. Okay. So see this flowchart here. Read the next bill. Shop as S and amount as A. If the S is already in the totals, then you have to just increment the total by A. If it is not existing, then you have to create a total yes variable and you have to set it to the amount A. Okay. So after finishing this process, you are going to check whether if the total is greater than max. If it is greater than, then you are going to set max is equal to total, and and you are going to end the iteration after doing this process. So at the end of this process, you will be getting the maximum total seen so far. Okay. Let us have an example walkthrough. See, for the SV stores, in step 1, for the SV stores, the total amount is 567. Right? See, the total amount is 567. So, for SV stores, I'm keeping the variable as SV and the amount is AMT. So, the total for SV stores is set to 0 first, right? Total for SV stores is set to 0 first. So, see here, SV stores amount. So, the SV stores amount is new variable here, right? New variable. So, I am going to create a variable called total SV, which I am going to set it equal to amount. Since it is a new variable, see, since it is a new variable, I have to set the total. I have to set the total is equal to A. So, the total of SV is equal to amount, which is 567. That's why I'm getting the value 567 here. Okay. So next I'm going to get Big Bazaar. Big Bazaar is a new variable. So I'm going to initialize a new variable called total big, which is equal to the amount, which is 1525. Okay, 567, 1525. No sun general, so dash. And then the third one is SV stores. SV stores again. I'm getting it again. So it is a existing variable. So I have to just increment the total of SV. The total of SV is equal to 567 plus this amount, which is 567 plus this 1341, which is 1908. Okay. So again I'm getting SV stores. That SV stores is an existing variable. So I have to add total is equal to 1908. Sorry, 1908 plus amount, which is 1908 plus 123, which is 2031. So this is how the iteration follows. Again, for step 5, I'm getting Big Bazaar. Big Bazaar is an existing one, right? Big Bazaar is an existing one. So I have to just increment the count. So total big is equal to 1525 plus the bill value here is, the amount here is 1525 plus 4174, which is 5699. Okay. So the bill value for the Big Bazaar is updated to 5699. Then I'm getting Sun General for the first time. So I'm going to create a variable called total SG, and I'm going to initialize it to the amount, which is 354. So Sun General is 354. So I have to repeat all these process, and then I'm getting the total of SV stores as 7120, Big Bazaar as 13,284, and Sun General as 4009. So after finding the total of SV stores, it will be doing total of SV is equal to greater than max. See, max is set to 0. So the total of SV will be 7120 greater than 0. So this is true, right? This is true. So max is set to total of SV. So max will be 7120. Then again I'm going to iterate this one. So 13284 is greater than 7120. Now this is total of Big Bazaar, and this is the max variable here now, right? Since we have iterated this and did this one, I'm getting the max is equal to 7120. Now again 13,284 is greater than 7120. This condition is becoming again true. So now the max is updated to max is equal to 13,284. Now let us compare again the total of Sun General with the max variable. So 4009 is less than 13,284. So this condition is failing here. So I am not updating my maximum value. So maximum remains as 13,284. So the maximum total is 13,284, which belongs to this big bazaar shop. Okay. So this is how we count the get the total bill value per shop, and we find the max in one iteration. We are getting two things from one iteration: total bill value and the maximum bill from one shop, per shop. Okay. Now let us see how we'll be counting how many times a word occurs in a sentence. Okay, so now let us see a process how we'll count how many times a word occurs in a sentence. Okay, the big idea will be we'll be scanning the paragraph once. So for each word we'll be keeping a counter that tells us how many times it has appeared so far. The same process we have done before, but this is we are doing this for the words data set. Okay, so the goal is to count the frequency of the word in a paragraph, of every word in a paragraph. So we don't know words in advance. So for for each new word, we will be creating a counter is equal to 0, and then we will be making it 1. If seen before, we will be just adding 1 to its counter. Okay, and we will be ignoring all the punctuation, and we will be treating hyphenated words as single words. Okay, so see the algorithm for this process. We are going to be start with an empty set of counters. That is, word will be equal to this count, and we are going to read the words one by one. This is the iterator, and if the word is not in our list, we are going to create a new counter for it, and we are going to set it at 1. Okay, so first we are going to get it means, then we will be getting it counter, we will be creating an it counter variable, and we will be setting it to 1. Okay, so if you are getting a second word as was, then you will be creating a was counter variable, and you will be setting it to 1. So again, if you are getting some was word, then it will be 1 plus 1, which is 2. Okay, so this is how the iteration will be. So if the word is already in our list, we will be adding 1 to its counter. So after all the words are processed, each counter shows how many times the word occurs. To find the most frequent word, we will find the maximum count. Okay, so the iteration will start by reading every word, and if the word W is already in the counters, then we will just increment it, increment its respective counter, and if not, we'll be just creating a new counter called W is equal to 1, and then we will move to the next word. And after all this one, we'll take the maximum value as the maximum count. Okay, now let's see an example walkthrough. See, first we are getting a word called is it. This is a new word, so I'm going to create the it counter is equal to 1. Okay, I'm going to create it counter, and I'm going to set it to 1. And then I'm getting a word called was. This is also new, so I'm creating a was counter, and I'm setting it to 1. Okay, then I'm getting another new word called Monday. I'm going to create a Monday counter, and I'm setting it to 1. Again, I'm getting another word called morning, and this is a new word. I'm going to create a new variable called morning, and I'm going to set it to 1. After um, some words, I'm getting another time was. So this is seen before here. So I do not have to create a new variable for was counter. I have to just increment the existing was counter variable by 1 to get the was count. So the was will update with 2. So this is how this algorithm will work. Okay, so this is how we'll get the count how many times each word has occurred. Okay, so now let's move on to finding the second maximum in one iteration. So how we'll be finding the second maximum in one iteration? So we want the second highest value marks among all the cards, and if maximum 1 is the highest value, then maximum 2 will be the second highest values. So we will be keeping two variables, max 1 and max 2, where max 1 is the highest value and max 2 will be the second highest value. Okay, and we are going to update rules for each new values. If x is greater than max 1, max 2 is equal to max 1 and max 1 is equal to x. Okay, if x is greater than max 1, see, for example, let us have max 1 is equal to 4, max 2 is equal to 2. Okay, now if x is greater than max 1, let us take the x as 9. 9 is greater than max 1, which is 4. Then I have to keep max 2 is equal to max 1. So now my max 2 is 2. I am going to update this 2 to 4. See, max 2 is equal to max 1. So now my max 2 value is equal to 4 and max 1 is equal to x. So max 1 is 4. 4 is updated to x, which is 9. So my max 1 is equal to 9. So now the max value is 9 and the second max value is 4. See, we are incrementing, we are updating the maximum values, and I'm not only updating the first maximum value, I'm also updating the second maximum value. Okay, so else if max 2 is less than x is less than max 1, then max 2 is equal to x, else no change. Okay, and then we have to handle also duplicates carefully. Okay, so the algorithm steps are, I'm going to initialize max 1 is equal to minus infinity and max 2 is equal to minus infinity. So you have to either keep max is equal to 0 or max is equal to minus infinity, like this. Okay, so for each card with value x, if x is greater than max 1, then max 2 is equal to max 1. The same logic we have used here. I have said you with an example too. So max 2 is equal to max 1 and max 1 is equal to x, and else if x is less than max 1 and x is greater than max 2, then max 2 is equal to x. See, if it is also like this, for example, max 1 is equal to 9, max 2 is equal to 4 and x is equal to 5, like this. Else if x is less than max 1, see, 5 is less than max 1 and 5 x is greater than max 2. See here, x is less than max 1 but x is greater than max 2. Then I have to set max 2 is equal to x, that is max 2 is equal to x, which means I am going to set 4 to 5. Now the first highest marks is 9 and second highest marks is 5. So else we will be doing nothing, no updation. Okay, so after all the cards, maximum 1 will denote the highest value and max 2 will denote the second highest value. Okay, so see the flow chart here. I'm going to start by reading every value x, and if x is greater than max 1, then I'm going to move to this one. Max 2 is equal to max 1 and max 1 is equal to x, and if x is not greater than max 1, that is if x is less than max 1, then I have to check if x is greater than max 2. If yes, I am going to set max 2 is equal to x. If no, I am going to do any updates. I am not going to do any updates. Okay, then I am going to move this card to the next pile and I am going to end after all the cards are processed. Okay, so at the end, maximum 1 will denote the highest value and maximum 2 will denote the second highest value. Okay, so let's see an example walkthrough here. At card 0, we are having the value as 68. So x value is 68, where maximum 1 I am setting to 0 and maximum 2 also I am setting to 0. Okay, maximum 1 I am setting to 0 and maximum 2 also I am setting to 0. So here x is greater than max 1. See, 68 is greater than 0, right? Then I will be updating
I'll be updating max 1 is equal to 68 and max 2 will be 0. Here it is set minus infinity because we will be dealing sometimes with real numbers also. I am taking the marks contents here. So the values will be from 0 to 100 only. So you can consider 0 here. Okay. So see here, and then I'm having a card with the value x is 62. See here, x is less than max 1, but x is greater than max 2. So I have to update max 2 is equal to x. So 0 is set to 62. So the first highest value is 68 and second highest value is 62 now. Now I'm getting 57. 57 is less than 68 and 57 is less than 62. See, which means x is less than max 1 and x is less than max 2. So then there will be no updations. Okay. So the first highest max is 68 and the second highest max is 62. No updations. Okay. Then I'll be moving on to next one 42. Again 42. Again I'm getting. So for the next card, we will be taking the value as 42. Again, the value 42 is less than 68 and the value 42 is again less than 62, which means x value is less than maximum 1 and x value is less than maximum 2. So we will be having no change here. Then we see x is 87, which is greater than maximum 1. So we have to set maximum 2 is equal to maximum 1, that is 62 will be set to 68 and maximum see, when we get x is equal to 87, it is greater than maximum 1. Okay, which is greater than maximum 1. So we will be setting maximum 2 is equal to maximum 1. So 62 will be set to 68. Then we will be updating maximum 1 is equal to x, which means 68 will be set to 87. So now our maximum 1 value will be 87 and the maximum 2 value will be 68. Okay. So the values are updated 87, 68. So see here, then I am getting another value 71. 71. X is less than maximum 1. So there is no update here, but x is greater than maximum 2. So maximum 2 is set to x. So 68 will become 71. So the maximum 1 value is 87 and the maximum 2 value is 71. So this is how the finding the second maximum iteration will work. Okay. Now let's move on to how do we design flowcharts to find maximum value and also the card number. Okay. So see here, first we will be initializing start. Okay, start initializing two variables, max is equal to 0 and max index as empty. Okay, this is empty index. Okay, so if there are more cards in the pile 1, then we will be moving. If there are more cards in the pile 1, S means we will be picking a card X with value card X dot marks, and we will be moving X to the pile 2 and we will be increasing the index by 1. Okay, and if the cards marks is greater than X means then we will be moving to the S block where maximum is set to the card X marks and maximum index is equal to index which is 1. Okay, and see here, if this occurs as no, if the card marks is equal to, first we have to check the greater than condition and then we will be checking the equal to condition. Then if it is yes, we will be moving to append index to the maximum index. No means we will be doing anything, no updates. Okay, so at the end we will be having the highest value, max is equal to highest value and the maximum index is equal to the card number with that value. Okay, So let us have an example walkthrough. Example walkthrough on how this algorithm will work. First, index will be initialized like this, empty list. Okay. So the max marks will be empty, maximum will be 0, and this is the max indexed. And this is the initialization action. Okay. First step, that so there will be not much calculations here. Okay. Now my index is set to 0 and the marks I am getting is 68. Okay, so the marks I am getting is 68. So 0 is not greater than 68, right? 0 is not greater than 68. So I am not moving to this condition. I am moving to this part, no part, where I will be setting max is equal to card x dot max marks. So maximum will be set to 68 here. So maximum will be set to that cards mark. Okay. And the index is 0 since we are taking the 0th card. Okay. 0th card. So next I am taking the card with the index as 1. Okay. First index card where the marks is 62. Here cards mark is less than max. Okay, cards mark is less than max. So I'm moving to the no condition. It is not equal, it is less than. So I'm moving again to the no condition. So I'll be doing nothing. Okay, no updation, same max is equal to 68, no change. Okay, again I'm getting 57. 57 is less than 68. That is the card x is less than maximum. So here greater than condition is also failing, so no. Equal to condition is also failing since I am getting 57 less than 68. So again I will be going to no, so I will be doing nothing, no updates. Okay, then see here I'm moving to the fourth index card where the value is 87. So 87 is greater than 68. So 87 is greater than 68. So I will be moving on to this S condition where I'm going to set the maximum is equal to cards maximum cards mark. So maximum is equal to, so it will be updated from 68 to 87. Okay, 68 to 87. So maximum is set to 87. Therefore maximum mark is set as 87 and the maximum index will be set to 4. Okay, this is the new max. Okay, and then again at the 11th index I'm getting 97 where 97 is greater than 87. Therefore the maximum variable is updated to 97 from 87 and the maximum index is updated to 11 as we got the maximum value 97 at the 11th index. Okay, this will be the new max. Okay, so see here, if I am getting again 97, it will be equal, right? 97 will be equal to 97. So I have to append the index to the maximum index list. Append means add. Okay, append means add. So at the 11th position also I have the marks as 97. At the 23rd position also I have the marks as 97. So 97 is the maximum mark. 97 is the maximum mark. So if two persons get the maximum mark as 97, I have to remember both the persons, right? So I'm just appending this index to the previous index. Okay, so 11 comma 23, appending means adding. I'm just adding it to the list. Okay, so 97 marks is achieved at 11th index and 23rd index. So this is how the algorithm works. Okay, now let's move on to from flowcharts to pseudocodes. How why text-based algorithms are easier to write, share, and update. So let us see. Flowcharts are easy to understand visually, but for larger procedures, we need pseudocode because text is easier to write, share, edit, and compare and collaborate on. So rectangles are process nodes, diamonds are decision nodes, the ovals are terminal nodes, and arrows shows the flows. So the running example is counting cards from pile 1 to pile 2 and moving them from pile 2 until none left. Okay. So see here. So the example flow chart Example flowchart idea is start. I'm going to initialize account variable is 0, and I'm in pile 1. I'll be moving. If I'm having more cards in pile 1, I'm going to pick a card and I'm going to move it to the next pile, and I'm going to increment the count variable as count is equal to count plus 1. Okay, I'm going to increment it. Then if not if no more cards are present, I'm going to end that process. Okay, so let us understand why we are not relying on the flowcharts alone, because bigger flowcharts can be bulky and it may occupy space, and we sometimes cannot contain a flowchart inside one page. Okay, and it will be hard to share and collaborate on, and it will be hard for another person to edit without redrawing. Okay, and it will be hard to compare version and track changes. So we'll be using naive text version. The one way to write the flowchart as numbered steps. Okay, so at 0 we'll be starting. At the first step we'll be initializing the count is equal to 0, and the second step we'll be checking if the pile 1 has more cards. The third step, if no more cards, we are going to end the process, and fourth step we are going to pick a card and move it to the fifth step we are going to move it to the pile 2, and in sixth step we'll be incrementing the count to by 1. Count is equal to count plus 1, and in seventh step we'll be going back to the step 2, where we'll be checking if there are more piles. If there are no more cards in the pile 1, then we'll be ending the process. So this works. This naive text version works, but it is very clumsy, and so because the text is linear and they need step numbers or jumps. Okay, so this is what we call as pseudocode. First, we are initializing count is equal to 0. While pile 1 has more cards, we are going to pick a card and move it to pile 2, and then I'm incrementing count is equal to count plus 1. Okay, so pseudocode is an informal text way to describe a computational process. So key pseudocode ideas are, for assignment you are going to give a value to the variable like count is equal to 0. For conditional or repeated execution, we will be using while or if or like that. So braces will help us show which steps belongs to which block. Okay, and in pseudocode we usually read from top to bottom unless a structure like while changes the flows. So what changed from flowchart to pseudocode? Instead of arrows and step numbers, pseudocode uses structure. It will have a sequence of line, and it will have a while loop for repetition, and there will be blocks or braces for separating each conditions. Okay, so this makes the algorithm shorter and clearer. So what are all the common traps? You have to understand which loop to use. So a while loop or for loop or if loop, you have to know which loop you will use to get the required answer. Okay, so this is the only drawback. Now let us see some other examples for pseudocodes for iterations and for filtering. Okay, so for example 1 is sum of all the max marks. Okay, example 1, sum of all the max marks. So see the flow chart. I'm going to start and I'm going to set sum is equal to 0. If there are more cards present in the pile 1, then I'm going to pick a card X and I'm going to move it to pile 2, and then I'm going to take sum is equal to sum plus X dot max. So I'm going to convert this flowchart to pseudocode, where I'll be setting sum is equal to 0. While pile 1 has more cards, I'm going to pick a card X, and then I'll be moving it to pile 2, and I'll be setting sum is equal to X dot sum is equal to sum plus X dot max. So X dot max means max marks of the current card X. Okay. See another example. I'm going to find the count of boys and girls. Okay, I'm going to find the count of boys and girls. Okay, so see here I'm going to start and I'm going to initialize two variables. Boys is equal to 0 and girls is equal to 0. If there are more cards in the pile 1, then I'm going to pick a card and I'm going to move it to pile 2. If gender is equal to boy, boys is equal to boy plus 1. Gender is equal to girls, girls is equal to girls plus 1. Okay, you do not need a variable sum here, you will need the variable boys and girls here. Okay, boys is equal to 0 and girls is equal to 0. While pile 1 has more cards, pick a card X and I'm going to move it to the pile 2. If the gender is boy, boy is equal to boy plus 1. Else, if gender is not a boy, it will obviously be a girl, right? So else girls is equal to girls plus 1. So X dot gender denote the gender of the current card. Okay, let's see the third example, maximum max marks. How do we find the maximum max marks? So I'm going to start and initialize the maximum variable as minus infinity. See, maximum variable as minus infinity and the maximum index is minus 1. And while pile 1 has more cards, I'm going to pick a card X and I'm going to move it to the pile 2. And if X dot max is greater than max, suppose I'm getting a value as max, max marks as 68 and it is greater than minus infinity, right? Then I'll be setting maximum mark is equal to 68 and maximum index is equal to 0. Okay, so I'll be repeating this while loop until I have more cards in pile 1. If I do not have more cards in pile 1, I'm going to end the process. Okay, and see the example pseudocode for finding sum of max for boys, sum of max for boys. Sum of boys is equal to, sum boys is equal to 0. While pile 1 has more cards, we are going to pick a card X and I'm going to move X to the pile 2. And if gender is equal to boy, gender is boy, sum boys is equal to sum boys plus X dot max. Okay, so it will add the max marks of the students who are all boys. So you will get all the male students total marks in max. Okay, so this is the pseudocode to find the sum of max for boys. Okay, and let us see the pseudocode for finding the average max marks of all students. Okay, average marks of all students. For that I'll be initializing two variables. Sum is equal to 0, sum is equal to 0 and count is equal to 0. Okay, sum is equal to 0 and count is equal to 0. While pile 1 has more cards, I'm going to pick a card called X and I'm going to move X to the pile 1. Then I'm taking sum is equal to sum plus max, and count is equal to count plus 1. So this variable sum will have the total max marks. Okay, and this variable will have the count of all the students. So when average is equal to sum divided by count, which means that you will be dividing the total max marks by count of all the students, which will ultimately give you the average marks of all students. Okay, so this is the pseudocode for finding the average marks of all students. So remember these things generally so that you can answer these types of questions easily without taking much time. Okay, remember these pseudocodes structure. For average, the structure will be like this. For finding the sum, the structure will be like this. For maximum, the variables will be initialized like this. If you remember, if you try to understand and remember these structures, it will be easy for you to analyze the pseudocode in the exam, in the qualifier. Okay. So the next one is representing the card data as tables. This is easy for you. You have to convert each fields into rows and you have to list them down. Okay, so for the first sample card you are having id as a id one variable, name one variable, gender one variable, date of birth, city, max, physics, chemistry, total. These are all some variables. Okay, you are going to keep these variables as rows, and as we get our cards, we'll be entering these values into that table. Okay, this is very easy for you. There are 9 attributes in this sample card, and you are going to convert these attributes as rows, as the first row in a table. Then as you get consecutive cards, you will be you will be entering the value of those respective attributes inside this table. Okay, so let us see how do we represent the shopping bill data in a table form. Then we'll be using one row for each item, and the duplicate will be fixed in every row. Okay, see, in data set, there should be no duplicates, there should be no repeated items, as it will mess with our calculation. So if you have if you have Akshaya's bill for 5 items, those 5 items should be unique. Okay, it should not be repeated. So if we duplicate, then the total marks will also be duplicate, they will become wrong. Then we'll be doing our interpretations on a very wrong data. So you have to be careful with unnecessary duplications. Okay, so this is simple, as we are just converting a data into a table. And then we are going to deal with the famous birthday paradox and nested iteration. So in a group as small as 22 through 24 people, there is more than 50% chance that two people share the same month and day of birth. Okay, so for this we will be doing an experiment with 30 cards, and each with the birth date, a month and day. So let us see if any two people share the same date of birth. See here, for that we will be using a naive approach or nested iteration. So we check one card against all the others. So the outer iteration we will be having one, okay, and the inner iteration we will be comparing it with others. Okay, the outer iteration will remember the outer iteration will remember the scene pile, while the inner iteration will be comparing the cards. Okay, so if we are going to check if anyone else has 9 October, and if the match is found, we are going to stop this iteration. If no match is found, we are going to finish this inner iteration, and then move the outer iteration, this that is outer iteration, to another card. Okay, outer iteration to another card. So see here, to optimize this procedure, when comparing a new card, we only compare it with the cards we haven't seen yet. Okay, so first we are taking Abhirami, who was born in 9th October. If no match was found for her in this piles of card, in this 30 cards, then we will be simply moving Abhirami to another pile, second pile. Okay, and then we will be not touching this Abhirami again, as we have completed the process for her. No match was found for her. So this is what they are saying. When comparing a new card, we only compare it with the cards we haven't seen yet. So when you take the second card, you will not be comparing this with the Abhirami card, since you have already cross-checked Abhirami with all these cards, right? So when you take the second card, you will not be comparing this card again with this card. Okay, this is what they are saying. So when you take the first card, you are going to compare it 29 with 29 others, and when you take the second card, you are going to take the you are going to compare it with 28 other cards, and if you take the third card, you are going to compare it with the 27 others, and the 30th card is compared with only one other card. Okay, so the results from the 30s cards will be, you will be finding some match. So if you find some match, then the birthday paradox is true. So when in a small group of people, there is a high percent chance then that they can share the same birth month and date. Okay, so after we found the match, the iteration will be over and the process ends. Okay, so why do we use the nested iteration for this birthday paradox? We must compare every item with every other item. One simple loop cannot do this, so we use a loop inside another loop. So outer loop is used to fix one person and remember that whole person for the entire iteration, while the inner loop compare this fixed person with the rest persons. So more loops inside means much more work. So we have to carefully choose the loops if they are necessary or not. Okay. So there is also another smart approach for the birthday paradox. Okay, there is also some another approach for birthday paradox which is not much necessary for that for us. This nested iteration is the very effective method, so we can simply skip this. Okay, now let's move to nested iterations and binning. Okay, so counting comparisons the smart way. So the problem is we often need to check if any two items are same, like same birthday, same marks, same phone numbers, like that. That means comparing each item with every other item. So nested iterations compare everything with everything. See, for example, if you are having 5 elements named A, B, C, D, E, then the first element A is compared with B, C, D, E, and the second element B is compared with B, C, D, E. Sorry, B is compared with C, D, E. C is compared with D and E. D is compared with E, and E has nothing to be compared with, so 0. So for A there will be 4 comparison, B there will be 3 comparison, C there will be 2 comparison, and E there will be 1 comparison. So the total number of comparisons will be 10. Okay. So in general, you can calculate the number of comparisons by using this formula, n into n minus 1 divided by 2. Okay. So see here, this is the formula. There are 3 ways to get n into n minus 1 divided by 2, which will be the sum of sequence n minus 1 plus n minus 2 up to 1, or we will be choosing the data as pairs. Okay, choosing the data as pair means n divided by number 2, that is n into n minus 1 divided by 2, or we will be dealing with the pairs directly. So the total pairs will be n cross n, and we will be removing the self pairs. Self pair means 1 into 1, 2 into 2, like this. Then it will be n cross n minus n. Okay, so removing the duplicate means n cross n minus means n into n minus 1 divided by 2. Right, we are taking the n common here, which means n into n minus 1 divided by 2. So how fast this nested iteration grows, if n is equal to 10, then n into n minus 1 the whole square is 45. Sorry, which is 10 into 9 divided by 2 is 45 divided by 2. Okay, so 100 means 100 into 99 divided by 2 is 4950, like this. So only one zero has increased, but the number of nested iterations has grown triple the size, right? So this is how the nested iterations are more effective. But if you introduce nested iterations in places which is not even necessary, then it will add much work to a simple process. Okay, so we have to be careful in choosing nested iterations. Okay, now let us see another example for nested iteration. A loyal customer has made many visits to the same shop. So we are going to pick one bill and compare it with all other bills to see if the same customer visited a different shop. Okay, so first we will be picking Abhinav, then we will be fixing that person, then this is the outer loop. I'm going to compare this person Abhinav with each other card. This is the inner loop. So this is how the nested iteration works, right? So see here, I'm going to pick Abhinav, this is the fixed card. Then I'll be comparing Abhinav with all these cards inside. Okay, so this is how this is the outer iteration. Outer iteration will pick Abhinav, and then Abhinav is compared with Advait, Rajesh, Akhil, again Abhinav, again I'm getting Abhinav. So inner iteration will check all other bills with customer equal to Abhinav. Okay, so the Abhinav bills are found at Big Bazaar, SSV stores, and more. Okay, so he has visited more than three different shops, so he is not a loyal customer. So this is how the nested iterations is used to find loyal customers. Okay, so the outer iteration has picked up the first card and the person is fixed as Abhinav, and then the inner iteration is comparing this person Abhinav with other cards to check if he is repeated in any other different shops. So second time I'm getting Abhinav from SV stores, first time I'm getting from Big Bazaar, and third time I'm getting from more, and the store is not specified but it is not equal to Big Bazaar or SB stores. So he is not a loyal customer. He has scattered off to every shops. So he is not a loyal customer. So this is how the nested iteration is used to check the loyal customers. Okay. So you don't have to remember all these stories. You have to remember how the concepts are applied here. Okay. You have to just remember how the concepts are applied here. So now we are going to use some pseudocodes to make study groups to reduce comparison. We are going to find the pairs of students who can help each other. So the problem is we want to find students who can help each other. The idea is the pair should be such that one student is strong in mathematics and the second student should be strong in physics, and their total marks should be similar. So this avoids one student feeling superior or doing all the helping. So the naive approach will compare everything here. So it will pick one bill and compare with all other bills of the customer. So this require nested iterations, which is very costly. So we are going to pick one customer. This is the outer iteration. We are going to fix that customer and compare with every other bills, all customers. So the number of iterations will be n into n minus 1 divided by 2, which is 30 into 30 minus 1 divided by 2, which will be 450 comparisons. Okay. So see, the smart approach is we are going to bin by total marks. So put each students into a bin based on the total marks. So we are going to classify the students according to their range of marks. So 150 to 175, 175 to 200, 200 to 225. I'm setting some limits and I'm going to classify the students according to their marks. So after classifying, I'm going to move inside each bin. Okay, the first step is to classify the students under each bin. Okay, then I'm going to move inside each bin, and I'm going to split the students into two groups. Okay, higher in mathematics than physics and higher in physics than mathematics. So after doing this splitting, I'm going to pair students from these two groups so that they can help each other in each subject. So a student who is higher in maths will help a student higher in physics to score more in maths. A student who is higher in physics will help a student higher in maths to score more in physics. So in this condition, this one will be an achiever in physics and this one will be an achiever in mathematics, so that they won't feel superior also. Okay, so this top bin, they will not be needing any pairing as they are usually very high achievers. Okay, so this is a method called binning. This method is called binning, which means creating some continuous values, and we are classifying the students under this, and then using this I'm going to classify the students under two classes, higher in maths and higher in physics, higher in maths and higher in physics. and then I'm going to pair the students from these two categories and make them study together. Okay, and then there are some procedures, parameters and contracts for us to remember. Here also we'll dealing with the birthday problem. See, we are going to pick one card and search it with the rest. So picking one card is the outer iteration and searching it with the rest is called as the inner iteration, right? So Rahul is born on 30th April. So if 30th April is found, we are going to find the match and stop the process. Otherwise, we are going for no as an answer. So we will be checking all the other cards, right? So now let's turn this into a procedure. This task is the same for any card or date. So like let's write this as a procedure. So the input parameters will be target date and deck will be all the other cards. So the output will be yes or no, right? So the procedure will be search same date where the variables are target date and deck. So for each card in deck, if card dot date, okay, if card dot date is equal to target date, then you are going to return yes. If not, you are going to return no. Okay. So for each card in deck, if card dot date is equal to target date, return yes. Otherwise, you will be returning no. Okay. So contract means what do I expect? So what do I expect? When I call this procedure, what do I expect? It will be the output. So if I found the match, I'll be getting yes. If I do not found the match, I'll be getting no. This is the contract. Okay. So what happens to the data I gave it? There will be no side effect. Okay. There will be no side effect. Sometimes there can be some side effect to the data and there will be any side effect can be allowed. So see, contract means when I do this procedure, when I call this procedure, what will be the output I'll be expecting? If I found the match, then it will be yes. If I do not found the match, then it will be no. So either the answer will be yes or no. Okay. So this is what we call as procedures, parameters and contracts. So this is called the search same date is called the procedure. The target date and the deck are the parameters and the answer we will be expecting yes or no is the contract. Okay, yes or no is the contract. The procedure we are doing searching same date is the procedure. Okay, the process we are doing searching same date is the procedure and uh, the variables which are contributing to this procedure will be called as the parameters and the answer we are expecting as the result of this procedure yes or no will be the contract. Okay, so now let's move on to the final concept of this revision session, nested iteration in an action. So resolving pronouns in a paragraph. So in a paragraph, pronouns like he, his, she, her refer to someone who is being mentioned earlier, right? So a computer must figure out which noun each pronoun refers to. For example, Swaminathan was reluctant to open his eyes. He does not like the dismal yellow building. So here the his refers to Swaminathan and he also denotes the Swaminathan. So the outer loop scans the paragraph from the beginning and it finds a noun. Okay, and the inner loop, whenever sees a pronoun, it will compare it with the compare it with the noun and see if the pronoun is actually representing this particular noun. Okay, so see here, the outer loop scan the paragraph from beginning to the end. Inner loop, whenever we see a pronoun, it is going to search backwards and find the nearest noun. Okay, so Swaminathan was reluctant to open his eyes. Pronoun. So I'm going to move backward and I'm going to locate the noun Swaminathan. So his is referring to Swaminathan. Okay. So this is how the nested iteration idea work for resolving pronouns in a paragraph. So see let's see how we resolve pronouns step by step. So the paragraphs are Swaminathan, which is noun, his pronoun, he pronoun. Okay. So I'm going to read the word here, and when I meet with his, then I'm going to move backward and I'm going to refer to the nearest noun, which is Swaminathan. Again, when I hit he, I'm going to move backward and then I'm going to the nearest noun, which is Swaminathan. This he is also referring to Swaminathan. Okay, like this. We go back to the nearest applicable noun. Nearest applicable noun. It can be anything. It can never have to be Swaminathan alone. It can be anything, Vedanayakam, anything. Okay. So we go back and find the nearest applicable noun. So what will be the contract of this procedure? We make a procedure to resolve the renoun. So the procedure is resolve renoun. The parameter is the deck. Okay. So we are going to search backward in the deck to find the correct noun. Return the noun. So the output of this procedure will be a noun. So the contract will be the noun. So the contract must ensure that it is returning the correct noun and it is returning the deck in exactly the same date. There will be no side effect in the chord order or positions. Okay. So this this is the end of today's session. Okay. So this is the end of today's session. This is the part 2 of our best one shot CT video in 2 parts. Part 2 was already released. You can see the link for that playlist in the pinned comment. If you found this revision session helpful and want to complete qualifier preparation with live classes, one-to-one mentoring, 24/7 doubt support, structured practice, previous year paper discussion, and our newly launched qualifier crash course, call the number provided in the pinned comment below. If you found this video helpful, don't forget to like, share, and subscribe to the channel so you never miss our IIT Madras BS Qualifier content. Thank you for watching. Keep practicing, stay consistent, and I'll see you in the next revision video. Until then, all the very best for your IIT Madras BS Qualifier. Let's crack it together.